Hello, welcome to this video 7-3, and today we're going to talk about differential equations, and specifically how do you find a particular solution to a differential equation. Alright, so what is a differential equation? Well, just remember that a differential equation is the equation for a derivative, but usually in terms of y or x, or y and x, okay? And if you're in a different context, you may see different variables. The most common differential equation in context, your independent variable will be t for some type of time, okay? Now remember, the big idea here is that a differential equation is a derivative. This is a derivative. Now, we have worked with, in this unit, a whole bunch of differential equations, but we've worked with it in that aspect, that it's a derivative. Now, here are examples of differential equations that you can see. dy over dx equals 2xy. dy dx is equal to sine of x over 3 minus y to the power 2/3. So on and so forth. This example, dh dt here, you can see that this is in terms of h as your dependent variable and t, your independent variable, okay? So that one you would see like in a contextual problem. And then here we have y prime is equal to y squared over natural log of x. If you ever see a differential equation where they say it is equal to y prime, this is the same thing as dy dx, and that's going to be important. When we go ahead and solve, when we want to find a particular solution, we will want to be able to separate dy and dx, okay? So let's go ahead and talk about how we solve differential equations, or how we find particular solutions of differential equations. Given a differential equation, dy over dx is equal to some value, then y is equal to f of x is the particular solution to a differential equation, okay? And this just means that if I am given the derivative dy dx, the derivative of y with respect to x, then I need to go ahead and find what y is equal to. Y is equal to f of x. What is the function? Now this is going to require integration. You're undoing a derivative, okay? But what we first have to do is work with the derivatives, okay, that involve both x and y. So in AP Calculus, the only differential equations that we'll be working with or asked to solve with, they will be separable. Separable. So we first, in order to integrate, we have to separate x and y. So I'll go ahead and I'll show you example number 1 here. Dy dx is equal to 2x times y plus 3. Go ahead and separate the variables. Well, I'm going to move my dx over to the other side. Now, dy dx, this is a derivative with respect to x, and mathematically, technically, what we're doing is not totally legal, but it works anyway with what we're doing here. We treat it as a fraction. It's not really a fraction, but we treat it like a fraction. So I'm going to multiply this by dx, okay? And thus I have only dy on this side. Now notice too, I have a y plus 3 factor here. Now I'm going to go ahead and I'm going to divide this whole side by y plus 3. And I'll divide this side by y plus 3. I'll put it as 1 over y plus 3, right? That's the same thing as dividing. Okay, and thus I have separated my variables. 1 over y plus 3 dy is equal to 2x dx. Now you may be asking yourself, why, Schwarberg? Why is there y plus 3 in the denominator? Why is dy not in the numerator? Well, I like this format because this should remind you of an antiderivative rule, and here's kind of what your brain should be thinking on this, is that the integral of 1 over x, right, which is the same thing as the integral of x to the power negative 1 dx. Don't crucify me for not having the dx on the first one. This is the natural log of the absolute value of x. So this is an antiderivative rule. It's very, very common. So I like setting it up in this manner. Okay. So That's just separating. I want to be able to separate. This is going to be our first and second steps when we are finding a solution. And there's two types of solutions when you're dealing with differential equations. Okay, and I'll get into those in a bit. But the first thing that we're going to do is we're going to multiply both sides by dx. You saw me do that first. And then we're going to go ahead and separate the variables by multiplying or dividing if necessary. Generally, you're going to have your y values on the left and your x values on the right. Okay, and that's just most common with the setup. Okay, then step 3, we are going to keep on the integration train. We are going to integrate both sides next. Now be prepared to use u sub, and we'll get into an example with that. Okay, and then this is where we will get what's called a general solution. Once we integrate, we'll get what is called the general solution. Okay. Sometimes, though, most of the time, they ask for a particular solution. Particular solution, well, you're going to have to use an initial condition that is given. And using this, we'll find the constant of integration. If this doesn't make sense, in a second, it will. And then lastly, we will solve the final equation for y. We'll get y by itself. All right? Those are the steps. If you ever get confused, go back to the steps. Step 1 and 2 are pretty much kind of the same thing. All right, here we go. Here is the first example. Consider the differential equation dy dx is equal to x plus 1 over y. Find the particular solution y equals f of x given f of 1 equals negative 4. Okay, what I'm going to do first is I'm going to go ahead and take my differential equation dy dx, and I'm going to begin to separate this. So I have x plus 1 over y. Okay, I'm going to go ahead, I'm going to multiply both sides by dx. Multiply both sides by dx, so that cancels. And we get dy is equal to x plus 1 dx over y. We'll go ahead and multiply both sides by y. Okay, and we get y, dy, is equal to x plus 1 dx. There you go. On the AP exam, these problems can be anywhere from 4, 5, 6 points on one example, finding a particular solution. What you've just done, separating the variables, that's 1 point on the AP exam. Now, the next thing that we have to do, right, that was steps 1 and 2 from above, is we have to go ahead and integrate. I'm now going to integrate these two sides, on the left side and the right side. The integral on the left side gives us y squared divided by 2, so this is 1/2 y squared. And then on the right side, the integral of x with respect to dx is 1/2 x squared. It's the same, just a different variable. And the integral of 1 is just x. Now, these are indefinite integrals, and that requires adding a constant of integration because I'm doing an antiderivative. Well, if I differentiate this, I gotta end up back with these, okay? And I hope you see that if I took a derivative of each of these, I would end up back here. That's one way you can check your work when you're integrating. And I have to add a plus c. Now notice I only added the constant to the right side, and this is common convention because if I were to add a constant to both sides, let's say if you get in the camera here, if I were to add a constant to both sides, let's say this side is 2, this side's 5. Okay, I have a constant on both sides. Well, if I move this 2 over to this side, okay, now, right, subtract 2 on this side, subtract 2 on this side. Now I have 3 on this side. Well, isn't that still a constant? So rather than putting a plus c on both sides, we just tend to put the plus c on the right-hand side. Okay, so there you go. You get 1 point again for separating. I'll put a plus 1 right here for separating. And then you get 2 points generally for integrating correctly. Okay, it could be less. This one was pretty easy. I wouldn't be surprised if this was an AP exam question where that would just be 1 point. Your next point comes from solving for c. Now I have to solve for c. How the heck do I solve for c? Well, they gave us an initial condition. They say the particular solution given f of 1 is equal to negative 4. Now this is an x value and a y value. So all we do is we plug these in. Okay, so I have 1/2 negative 4 squared equals 1/2 1 squared plus 1 plus c. I'm just going to plug in x and y, and this will help me find out what c is. So if I go ahead and solve this, we get 16 divided by 2. That gives us 8. This looks like 1.5, those two combined, plus a constant. Okay, solving for c, we get c is equal to 6.5. Okay, so there's my constant. Okay, that means that my equation is 1/2 y squared equals 1/2 x squared plus x plus 6.5. Now, I have to go ahead and they want the particular solution. That's y equals. I do want to point out this right here is what we would call a general solution. And it might even be solved for y if you're seeing these. The general solution where I have a constant. It could be anything. It could be an infinite amounts of equations because c could be anything. This is just the general solution. A particular solution uses a point. So when we plug in this x and y value, this is all of a sudden our particular solution. So I do want to go ahead and I want to solve for y. So I'm going to multiply both sides by 2. This would give me y squared is equal to x squared plus 2x plus 13. And then if I go ahead now and solve for y, I take a square root. So y is equal to the square root of x squared plus 2x plus 13. Now when you're solving an equation for y squared and you take a square root, you generally have a plus or a minus. Wouldn't you agree? Now in this case, I'm only going to take the negative solution. Now the reason for this is if I were to go ahead and look at the equation y squared equals x, and then to solve this, plus or minus root x. This graph looks something like this and like this. This is not a function. I need a function. So I have to restrict my function, restrict the range. So generally, you're either going to only have the top curve or the bottom curve. So it will pass the vertical line test. Now, in this instance, I'm taking the bottom curve. Now, why am I taking the bottom curve? Well, it has to do with my initial value. My initial value was negative 4. My y value was negative. So I want the negative or the decreasing function, the negative slope. Okay? And that's how we get our particular solution. I don't know what that was. Boom! There it is. Example number 2. Oh, example 3, I guess, if you count that separating one. All right, for this one, I would like you to pause me and just separate these. I want you to check your separation skills on this solution, and then I'm going to come through, do it, and then take us the rest of the way on this example. So go ahead, pause me now, and separate. Okay, hopefully you went ahead and separated. If you did that correctly, you should have gotten 1 over y dy is equal to 2x dx. Again, there's your 1 point on the AP exam. Okay, I'm going to go ahead and integrate now. So I'll integrate, and we get the natural log absolute value of y is equal to 2x squared divided by 2. The 2's cancel, and we get a plus c. Okay, so there we go. Just on the AP exam, there's 3 points, possibly 1 or 2 to 3 points. Now I'm going to go ahead and I'm going to utilize my initial value to 1 in order to find my constant of integration. So I have the natural log absolute value of 1. That's going to be 0. Okay, times x squared, that's 2, so 2 squared plus c. Okay, so we get 0 is equal to 4 plus c, which means that c is equal to negative 4. So here is our equation. The natural log absolute value of y is equal to x squared minus 4. Now I want to go ahead and I want to solve for y. So I need to undo the natural log. I'm going to remove my natural log by raising each side to the exponential function. So e raised to the power of natural log of y, e to the power of x squared minus 4. Okay, so I'm going to go ahead and do this, and we cancel out our e's and our natural log. Okay, we get absolute value of y is equal to e to the power of x squared minus 4. Now we do know y in this case. It's going through the point 1, so we can go ahead and drop our absolute values. Okay, and then there is our equation. Not too bad. All right, example 4. Example 4. Consider the differential equation dy dx is equal to cosine of 2x times the square root of 7 minus 2y. Find the particular solution y equals f of x, given f of 0 equals negative 1. Okay, so I'm going to go ahead and separate this first. So we get dy is equal to cosine of 2x dx times the square root of 7 minus 2y, and I'll go ahead and divide by that. It gives us dy divided by the square root of 7 minus 2y is equal to cosine of 2x dx. Now before I integrate this, I want to go ahead and kind of rewrite this. Now this is a power of 1/2. What I'm going to do is I'm going to rewrite this as 7 minus 2y to the power of negative 1/2 dy equals cosine of 2x dx. Now what I have to do for both of these is I have to do u substitution. Over here I'm going to let u be equal to 7 minus 2y, and therefore the derivative of u is going to be negative 2 dy. Okay, so I'll make those substitutions. Over here I have u to the power of negative 1/2 du. Okay, and I introduced a negative 2, so I'm going to have to balance it with a negative 1/2. Okay, so we have the integral, and this is equal to over here. I'm going to use a different variable because I don't want that. I'm going to use v. V equals 2x, and then dv is equal to 2 dx. Okay, so over here we have the integral of cosine of v dv, and I added in a 2, so I have to balance this with a 1/2. There we go. Okay, and we will integrate now. So now this gives us negative 1/2. The integral of u to the power of negative 1/2 is just going to be u to the power of positive 1/2, and I'm going to divide by my new power 1/2, and that's just multiplying by a reciprocal of my fraction times 2. Move my equal sign. Okay, now I'm going to swap back out to my y's. Over here it was 7 minus 2y. That's what u was. Okay, and over here we have 1/2 cosine of 2x. Oh, I got to integrate. Antiderivative, sine. Okay, the antiderivative of cosine is sine of 2x plus a constant. Whew. Okay, so lots of stuff going on here. Let me kind of clean this up. Here I got some 2's and a 1/2 that cancels, so I have negative square root of 7 minus 2y is equal to 1/2 sine of 2x plus c. Now my initial value that was given, okay, I'm going to go ahead and plug in. So we got 0, negative 1, 0, negative 1. So negative square root of 7 minus 2 times negative 1 equals 1/2 sine of 2 times 0. That's just going to be 0. So this gives us, it looks like negative square root of 9 is equal to 0 plus c. C is negative 3. So c is negative 3. Okay. And we end up with the equation negative square root of 7 minus 2y is equal to 1/2 sine of 2x plus, just kidding, minus 3. Whew! It's a long one, man. Okay, I found the constant. There we go. Now I gotta isolate y, and you're like, are you kidding me? Are you kidding me? We're almost there. Almost there. Okay? I'm gonna get rid of the negative. So dividing each side by a -1, dividing each side, each term, right? And each side by -1. This gives us square root of 7 minus 2y is equal to 3, a positive 3, minus 1/2 sine of 2x. Okay, I'm going to undo the square root by taking the power of 2. So 3 minus 1/2 sine of 2x. All of this raised to the power of 2. Almost isolated y. Now I need to go ahead and subtract 7 on each side. Negative 2y is equal to, oh my gosh, are you kidding? Whew, we're really flexing those algebraic muscles. Got to subtract 7, and then I'm going to divide by -2. So I'm going to divide each side by -2, which gives us y is equal to 7/2 minus 1/2 of this whole thing, 3 minus 1/2 sine of 2x quantity squared. That's it. There it is. I would box that answer, but I tell my students don't box it. Yet I constantly do it. So there's our particular solution. Whew! That was a good one. That was a good one. Did I box any of my answers up here? Oh, look at that. I did that. Don't do that. Don't do it. I was testing you. Did you tell me? Did you tell me? Did you yell at the screen? Don't box your answer. And up here too. What am I thinking? Oh my gosh. Whew. Don't do it. Okay. All right. Hey, that's going to be it. If you would like a challenge, maybe try one on your own. Here is the 2008 AP Calculus AB free response question number 5. This differential equation takes you through a slope field, a particular solution, and then finding a limit. Limit? What? That's it. Give me a thumbs up, like, subscribe. Check out @RadMathDad. I'll see you in the next one. Peace out.